Multiple Spanning Tree Protocol, MSTP, is the protocol used in network switches to prevent loops in the network. It keeps traffic flowing efficiently. MSTP uses Rapid Spanning Tree Protocol for rapid convergence, enabling VLANs to be grouped into a spanning tree instance. Each instance has a spanning tree topology independent of other spanning tree instances. This architecture provides multiple forwarding paths for data traffic, enables load balancing, and reduces the number of spanning tree instances required to support a large number of VLANs. It's like a traffic cop at a busy intersection, keeping traffic flowing smoothly and effectively. In this episode of Cisco Tech Talk, I'll show you some best practices for using multiple spanning tree protocol. Next. I'll start with some of the benefits of using MSTP. It introduces load sharing, which has the most impact on the effectiveness of your network. MSTP performs better than spanning tree protocol. Compared to per VLAN spanning tree, MSTP uses fewer resources, including BPDUs, CPU cycles, and transmit time. Once you've decided that MSTP is right for your network, a smooth rollout can be achieved with a little bit of strategy. Start by identifying and documenting all point-to-point ports, or ports that lead to another switch or router. Identify and document all edge ports, or ports that lead to an endpoint, like a PC or printer. Define which VLANs are participating in the migration. Keep in mind how a change on one switch can affect a different VLAN. Determine the order of operations for your network. Schedule downtime for your network or migrate during off-business hours. Start the migration at the core of your network and work down to distribution and then the access layer. When configuring MSTP, it's important to enable point-to-point ports to use PortFast. This prevents spanning tree from running on that port. The goal is to prevent that port from bridging the network to another set of open ports, which might result in loops if the switch received a better BPDU. The switch to gear facing ports could include a server, workstation, or a router. Given ports coming online to a network incur an STP calculation on the port. You can save time in CPU load by assigning the blocking status ahead of time. Be sure the ports on the switches are configured for full duplex transmission. In PuTTY, log into your switch with your username and password. After each command, you need to hit the Enter key on your keyboard. In addition, the ports in VLANs you enter may vary depending on your needs. This is just an example. To enable PortFast, enter the Configure Terminal command in Privilege Exec mode to log into the Global Configuration mode. Enter the interface mode for your specific port. In my case, I'll type interface gigabit Ethernet 1/0/1. Enter spanning-tree PortFast. An extension of this is to enable BPDU guard on edge ports. If a BPDU guard-enabled port sees that the port received any superior topology-changing BPDUs, it immediately shuts the port down with an error disable status. That would require you to access the switch and resolve the situation. In the CLI, to enable the BPDU guard, enter the spanning-tree BPDU guard enable command in interface config mode, and then enter. The next best practice is to map the VLANs to multiple spanning tree instances and not to the internal spanning tree. For best results, limit the number of instances you create. Even if you have valid network design considerations for multiple instances, it's recommended to have a single instance. Decide what VLANs to map onto the instance or instances. Choose a configuration name and a revision number that will be common to all switches in the network. Avoid mapping any VLANs onto instance 0. Keep in mind that when you edit the MSTI VLAN mappings, MSTP restarts. In interface config mode, enter exit to get out of the interface mode. Enter spanning-tree MST configuration to go into multiple spanning tree mode. Then, I'll enter instance 1 VLAN 1 to 10. The next recommendation is to place as many switches into a single region as possible. The BPDUs sent enable a switch to recognize itself as a member of a particular region. For the bridge to understand its membership in a given region, it must share the region name, revision number, and the digest computed from the VLAN to instance mapping. In config MST mode, I'll enter instance 1 VLAN 20 to 30, name region 1, revision 1, exit to get out of multiple spanning tree config mode, and then exit again to get back to privilege exec mode. The idea is to place the root bridge for the MSTP topology within the primary MSTP region, nested. This is achieved using the feature known as root guard, which enforces the root placement created by you. When a bridge receives a superior BPDU on a root guard activated port, it will immediately place the port in listening mode via a root inconsistent STP state. This prevents the forwarding of their inferior BPDUs, thereby preserving the designated ports on the root bridge of your region. That is why it's important to carefully select the root and backup route for each instance. In privilege exec mode, enter the configured terminal command to log in to global config mode. Then enter the command interface gigabit Ethernet 1/0/2 to enter that interface. Enter the spanning dash tree guard root command to enable root guard. Exit, and then exit. To save these configurations, enter copy, running dash config, startup dash config, and then Y to save the new configurations. There you go. If you follow these suggestions, you will have an efficient network that prevents loops and runs efficiently. Thanks for watching. I'll see you next time.